to my channel. Today we are going to work on limits, continuity. When does limit exist? Limit exists if left hand limit, that's limit as x approaches the point of limit of f of x is equal to right hand limit. So if this is your number line and you have a point, say A, you have to check the limit. If you have a curve, limit as you approach A from this side, and limit as you approach A from this side, are they equal? If they exist and are equal, then the limit exists at that point and is equal to what they are. Do you understand? Nobody answered.
Yes.
Okay. Alright. So an example. Let's take f of x to be equal to 1 if x is greater than or equal to 0, and be equal to minus 1 if x is less than 0. Let's check if limits at x equals to 0 exist. Okay. What is the limit as x goes to 0 from the, first of all, you can just draw it so you can see. So if x is less than 0, this is 0, and this is x, 1. If x is less than 0, we have minus 1. So let's locate minus 1 here. And if x is less than 0, excluding 0, it's going to be minus 1. And then if x is
Greater or equal to 0.
yes, so it's from here. It takes even 0.1 and then all the way. Now let's approach 0 from the left hand side. This is my left hand side, right? Approaching 0 from the left hand side, what do we have? We have the limit 0 from the right hand side. I'm coming to 0 from this side. What will you give me? 1. And the two of them exist, right?
Yeah.
But are they equal?
No.
No. So the limit of this function at x is equal to 0 does not exist. Do you understand? So limit as x tends to go 0 of f of x does not exist. That's how we write does not exist. Yeah. Now, if you can see clearly, you don't need to draw the graph. Do you understand? If you can, it's obvious from here. And if I'm coming from the left hand side, it's minus 1. And if I'm coming from the right hand side, it's plus 1. It's plus 1. So it's obvious from here. But if you are not seeing clearly, you can sketch the curve. Okay? Sometimes it may be difficult to sketch. You just, another way is to plug points that are close to 0 from the left hand side. A number close to 0 from the left hand side is like minus 0.1. Check. At when x is equal to minus 0.1, x is less than 0. So it's minus 1. So you can see that you can keep taking smaller values leading to closer to 0 from the left hand side to help you see. Some it will be very difficult to sketch. Okay. With this same function, let's take another example. Let's find the limit as x goes to 2. Okay? So, limit as x goes to 2 from the left hand side of f of x is what? From the left hand side is something like 1.99999. It's somewhere here. Everything around 2 is 1. So limit as x goes to 2 from the left hand side is 1. From the right hand side is also 1. So this means that since these limits are equal, then limit exists and it is 1. So the limit as x goes to 2 of f of x is equal to 1. That's clear, right?
Please.
Precious pause. Let's check out the continuity of a function. When do we say a function is continuous? A function is continuous if at a point f is continuous at a point x naught if 1 f of x naught exists. That's, I can plug in the point. It's not always that you can do this. You cannot always plug in the point. For example, if you have f of x is equals to tan x and you are given x naught to be equals to pi over 2, it is not always that you can plug in the point. If you plug in this, it's undefined. Do you
Even
understand?
for 1 over x too.
One over x.
And
Simpler function.
Even for f of x is equal to 1 over x, you cannot always plug in something. Example, f of x is equal, x naught is 0. Example, x naught is 0. You can't plug in 0 again. It doesn't make sense. So, f of x naught must exist first. Number 2, the limit of f of x as s goes to x naught will exist and is equal to maybe some L. And then finally, f of x naught is equal to L. So it's saying if I find limit as x tends to that point, it gives me a value. And that value it gives me must be exactly the same value as when I plug in the point into the function.
What of the left hand and right hand is not part of what?
Limits exist if left hand limit and right hand limit exist and are equal. So this is like a summary. Let's take some examples on continuity. We are going to check the continuity of these 3 functions at the given point. Let's take the first number. How do I look inside?
don't give me face shining in your face.
My face is glowing.
It's glowing.
Is it too bad?
No, I don't think so. What
Okay.
if it's bad? Is your face want to see?
Number 1.
Please write solution, please.
We have this. If we plug in x is equal to 2, we are having 0. And if we plug in this, we're having an issue at the bottom here.
For x minus 2.
Yes. So, but I want you to observe that this is different of 2 squares. This. So it can be simplified further. Okay? Before we start solving, let's try to simplify that further. We have f of x is equals to x squared minus 4 over x plus 2. This is the same thing as x minus 2, x plus 2, all over x plus 2. And this will give me what? X minus 2. Now we're going to check f of x naught. Does it exist? So if you had put x naught to be minus 2, you will see that f of x naught does not exist here. But it's not true. Okay? So let's see how it exists. Let's take f of 2 first. Let's solve for 2. F of 2 is what? When we put 2 here? 0.
It exists.
So it exists. That's the first one. Then the second one, we want to check for limit as s goes to x naught of f of x. So this is the function, the new function we have. As we approach 2 from the left hand side, see 2 on the number line. If we have 2 here, the close number you can think of is 1.999, right? If you put it here, it's still going towards there.
It's going to
The more you reduce it, the closer it gets to 0. So limit as s goes to 2 from the left hand side of f of x is 0. Right? Now let's check from the right hand side. We can have 2.00001 something 00. As it goes closer to 2, you see that this still goes to 0. Okay? So the limit as x goes to 2 from the right hand side of f of x is still 0. So that means that limit exists, right?
Yes.
And is equal to 0. So limit as x goes to 2 of f of x is 0. So therefore, C holds that f of 2, f of x is 0, which is this. What does it mean? F of x is continuous at CTS is continuous, okay? It's continuous at x is equal to as x is equal to 2. It's continuous at x. It's continuous at x is equal to 2. So let's do the second part of that. X is equal to minus 2. For the A part, if you put minus 2 here, what do you have? F of minus 2 is minus 4. Right? For the second one, if you had not done this, you would have been getting that f of minus 2 is not defined. And you might have immediately concluded that limits and the continuity does not, it's not continuous at this point, which is not necessarily true. So you should be open to manipulating and evaluating the function, playing around with the function until it gets to its simplest form, like this. Okay. The next one is limit as x goes to minus 2 from the left hand side of f of x. As x goes to minus 2, let's say this is minus 2 here. From the left hand side, this is your left hand side, so around here, a closed number is minus 2.001. Am I right, Abby?
Yes.
So as you keep increasing the zero, the number of zeros before the 1, you will see that this is going towards, what will it be going to? Let's put this inside here. What do we have? We have minus 4.001. As you keep increasing the number of zeros, you have a smaller number reducing to minus 4. So this is minus 4. And the same thing happens this way. So we have the limit as x goes to minus 2 from the right hand side of f of x is still minus 4. So what does that mean? It means that limit exists. Limit as x goes to minus 2 exists and is equals to minus 4. And you can see that the conclusion is obvious. F of minus 2 is this minus 4, so minus 4. Hence, f of x
It's continuous.
at x equals to minus 2. Number 2, decide f of x is equal to x at x is equal to 0. So let's check the continuity at x is equal to 0. What does it mean? You have f of 0 for the first part, A. F of 0 is equal to 0, so it exists. Then the next one.
I have a question. Are we substituting directly because we cannot simplify the function more than this? Is that why I substitute directly?
Well, one reason why I can substitute directly without checking is because it's defined at this point.
Okay.
If it was not defined at this point, I would check whether I can simplify the function to a function that it will be defined as. If I cannot, then I say it does not exist at that point, and I conclude that it's not continuous.
Okay, thank you.
So, f limit as x goes to 0 This is a straight line graph, okay? Where 0 is 0. This is f of x is equal to x. When x is 1, y is 1. Okay? So you see that both from the left hand side and the right hand side, as x approaches 0, it is 0. Do you understand? Left hand. So I don't want to stress myself. I know that the limit as x approaches 0 of f of x is 0. And then for the last one, since f of 0 is 0, then, and that is what the limit is, I can see that what f is continuous at x is equal to 0. Is that clear?
Yes, very good.
So, in fact, f of x is equal to x is a continuous function. It is continuous at every point in R. What does it mean for a function to be continuous everywhere? It means that for any x I pick in the domain, that f is continuous at that point. All these things hold at that point. So to prove it, you can pick an arbitrary point and show that it holds for all of them. Okay?
We are
Sometimes
saying-
it's not
if I pick
everywhere.
one. If I pick at x equals to 1, it's continuous. X equals to minus 1,
Yes.
it's continuous. X equals to 1 million,
It's continuous.
X equals to 1 trillion.
Yes. And to prove something like that, you can take arbitrary points. You can just take f of x. You can just take let x not be in the domain. You see that f of x naught is x naught, so it exists. Because x naught is in the domain and x naught is a real number, so it exists. The next one you say limit as x goes to x naught. Since it's a straight line graph, you are sure that the limit goes to x naught and then it holds. You can play around with different functions to see how the function changes, with the continuity of the function changes with the function you pick. So let's take the last one, number 3. We have f of x is equal to x minus 3 over x squared minus 9. Okay, if I plug in 3 into this function, I have 0 over 0. There's a problem there. Even if I plug in minus 3, I have minus 6 over 0. So there is a need to simplify the way we did the first function. So we're going to see clearly that this is difference of 2 squares. So I have x minus 3 over x minus 3, x plus 3. And this will cancel out, so I have 1 over x plus 3. So it is easy to see that f of minus 3 does not exist. It's undefined. Okay?
It's not defined.
So
But it's defined at 3.
it's undefined. So if it is undefined, I can conclude that f is not continuous. Because even after simplifying, it still remains undefined. Okay? It's not continuous at
X equals to minus.
x is equal to minus 0. And observe, I didn't have 0 over 0. Okay? It's 1 over 0. If it was 0 over 0, I would still need to do all those things they taught you on the graduate level or younger levels. You may need to do them. Some manipulations, maybe by differentiating or whatever. Okay, so this is I, and this is II. The II is f of 3. F of 3 exists, okay, because it's 1 over 6. Right? So this is 1 over 6. This is A. The next one, we check that the limit at f goes to 3 exists and is equals to something. So C3. 3 is somewhere here. So we can choose to go to 3 from the left hand side first. Going to 3 from the left hand side, we take a number less than 3, maybe like 2.99999, and plug it in here. You will see that as it approaches 3, it goes to 1/6. So we have limit as s goes to 3 from the left hand side of f of x is still 1/6. Next, we check from the right hand side. From the right hand side, we are having 3 points. So, what do we have? We have that it still goes to 1/6. The closer it gets, we have 3.00001. The closer it gets to 3, it goes to 1/6. You can plug in values to see that. And then you have that limit as s goes to 3 from the right. Of f of x is equal to 1/6. And that means limit exists, right? So this is equal to the limit as x goes to 3 of f of x. And then finally, we are saying that f of 3 is equal to 1/6. Hence, it's continuous. F of 3 is equal to 1/6. Hence, f is continuous at x is equal to 3. And that's all for this. And that's all for this examples. You can challenge yourselves to try checking the continuities of functions that you can give yourself, or you can check online and try to see if you can check the continuities of those functions. But let me give you one to try. Please check if you can solve this question yourself, and if it's continuous at x is equal to 5. If it is continuous at x is equal to 5, please tell me in the comment section that it is, and tell me what the limit is. See you in my next video. Please subscribe to my channel. Bye.